let's talk about body fluids. We have the intracellular fluid compartment, and then we have the extracellular fluid compartment made up of plasma and interstitial fluid. So here's a question to think about. Do you think pus is considered to be a body fluid? So keep thinking about that and you'll have the answer very soon. Fluids that are being excreted in the body or secreted are body fluids. We are 60% fluid. Shocking, right? That actually means that we are almost 40 liters of just body water. And that obviously depends on a variety of factors, but I think that's just an interesting fact to know. Body fluids play an essential part in body homeostasis, and so it's really important we maintain a constant volume and a stable composition of these. As we saw earlier, the fluid compartment is made up of the ECF and the ICF. The extracellular fluid makes up about 1/3 of it, and the intracellular fluid makes up about 2/3 of it. Also important to know is that the fluid compartment is higher in babies and adult males and the lowest in adipotic females with just about 50%. If you guessed correctly, then yes, pus indeed is a body fluid. Here are a few examples of body fluids. It's important to maintain fluid intake and output, as there's a continuous exchange of fluid and solutes with the external environment and the body all the time. So let's look at the sources of water input and output both. Water is added to the body by two major sources: ingestion in form of liquid or water in food, which normally adds about 2,100 milliliters per day, and then synthesis in the body by oxidation of carbohydrates, which adds about 200 milliliters per day. All in all, this comes out to be 2,300 milliliters per day on average. And then water output, you have an insensible loss from the respiratory tract in form of evaporation and then diffusion through the skin. There's also a water loss in feces, water loss through sweat, which again depends on the weather, and then through urine, which is actually controlled by multiple mechanisms, and then tears, again, which is subjective. All in all comes out to, again, a 2,300 milliliters per day average. It's really important to maintain this balance between them, and you'll see why. Okay, some facts about the ICF and ECF. ICF is about 40% of total body weight, whereas the ECF is 20%. And you'll see that this number makes up the 60% of body weight we keep talking about that is fluid. And something interesting to talk about actually is the Donan effect. So what is the Donan effect? It's the behavior of charged particles near a semi-permeable membrane. And sometimes what happens because of that is that the two sides don't have the same amount of charged particles distributed, along them. And you'll see this in terms of plasma and interstitium, wherein they're separated by really permeable capillary membranes, right? So even though we consider them to have a similar ionic composition, there's actually more proteins in plasma due to this effect. That is quite interesting, at least to me, but that is that. And now we'll look more deeply into the ionic composition of the compartments. As you can see from the picture too, there's large amounts of sodium and chloride as well as bicarbonate ions in the extracellular fluid, and then a small amount of potassium, calcium, magnesium, phosphate, and so on. In the intracellular fluid, on the other hand, it has large amounts of potassium and phosphate as well as magnesium and sulfate, and then almost no calcium ions and small quantities of sodium and chloride ions. And then also important to note is that there's large amounts of protein in the ICF, almost 4 times as much as in the plasma. These values that you see on the screen right now, the concentrations, right, in millimoles per liter, they are important from an examination point of view. So definitely go through these values, and multiple sources have some different ranges, but it's always good to know them. with every process comes regulation. So in the ECF, we have sensing done by the baroreceptors, the volumereceptors, osmoreceptors, and the juxtaglomerular apparatus. And this is sensing different things like vascular pressure changes, blood volume changes, osmotic pressure changes, and then also concentration of sodium and chloride ions. Control centers are in the hypothalamus and the brainstem. And then you have effector mechanisms, including the antidiuretic hormone, the RAS system, the ANP, mechanisms of thirst and salt appetite, and so on. Very important to keep the ICF and ECF isotonic because we don't want cells to be swelling up or shrinking. So an important ion of the ECF is sodium, and it's always tightly regulated. And this is because you don't want the isotonic property of these to change, right? Because it can cause, pathology. And we are looking into an edema. So what is an edema? It's a obvious swelling that is caused by fluid buildup in the tissues, and it mostly occurs in the extracellular fluid and a bit rarely in the ICF actually. And yeah, that is that. So I hope this was helpful, and that's all from me.